There seems to be some confusion about the homework that was given. So what I had asked everyone to do is to trace the path of the robot in a form of an equilateral triangle. An equilateral triangle is a triangle that has all the sides equal. Now when it has all the sides equal, all the angles are equal. Three angles of a triangle measures 180 degrees. So if you have three equal triangles, each angle would measure 60 degrees. So that's the basis of an equilateral triangle. Um, Now knowing that, we know that we would need the gyro for this. Uh, so first what we are going to do is we are going to start with the gyro block. Now as you move the EV3 to the right or the left, the gyro will always change the angle. So before you want to set this program, you want to reset the gyro. That will get it back to 0 degrees. Every time you reset the gyro, you want to pause the EV3. Now you don't want to pause it for a very long time, because as you keep using the gyro again and again and resetting it again and again, if you start using like 1 second pauses, this is going to prolong your program. When you are in a competition, you have just 150 seconds. You don't want to even waste a second. So try to use as little pause as you can, and 0.1 second should be okay. So why do we use a pause after the gyro? The reason we use a pause after the gyro is the EV3 brick functions very fast. It performs almost like 1,000 times a second. So if you don't pause the gyro, it might go to the next function and may not recognize the gyro has been paused, reset, not paused. So reset the gyro. Always after resetting the gyro, pause it. Okay, so now our EV3 is in position and the gyro is reading 0 degrees. So what's the distance it has to travel? It has to travel 40 centimeters. So for it to travel 40 centimeters, you need to use the move steering block. Nowhere on the move steering block it tells you to move that the EV3 can move 40 centimeters, because every EV3 robot will have different wheels. Our robot has wheels with a radius of 28 millimeters. So when you have a wheel with a radius of 28 millimeters, it has a circumference of 17.59 centimeters. So we will take 17.6 centimeters. What does that mean? A circumference of 17.6 centimeters means that in one motor rotation, the robot will advance 17.6 centimeters. But you want your robot to move 40 centimeters. So how many rotations should the EV3 move? So one rotation makes it move. So this is one rotation. You already have the motor on for rotations and you are on for rotations. One rotations makes it move 17.8 17.6 centimeters. But you want it to move 40 centimeters. So what you do is you take 40 centimeters, divide it by 17.6, and you get around 2.28. So in 2.28 rotations, the EV3 will advance 40 centimeters. So you got that. So every time, let's say I want it to move 60 centimeters, so I'll divide 60 by 17.6, and whatever answer I get, I will write in number of rotations, because one rotation is 17.6 centimeters. So okay, you got your distance right. The 2.28 rotations is going to make it advance 40 centimeters. Now 75 is a very fast speed. I usually try to make it slower. Faster it goes, more errors it's going to make. So let's go to 35. So let's advanced. It's going to go at 35 um, power. It's going to advance straight. It's not moving to the right or the left, and it's going to go for 2.28. Okay. Um, Now what do you want to do? You want the motors to stop. So you're going to take the motor block again, and what are you going to do? You're going to stop it. You're going to off the motors. Okay. Of course, every time you change a function, you may want to pause it. You may not want to pause it. I like pausing it. The EV3 takes a break and gets time to think. Okay, so it's paused. Now what do you want to do? Now in this program I'm going to teach you how to move in the clockwise direction. So the robot is now going to move to the right and create an angle of 60 degrees. So what's happening now? What's the angle on a line? On a straight line the angle is 180 degrees, right? So when the robot is moving to the right and it wants to create a triangle with an angle of 60 degrees, the gyro needs to move 120 degrees. Okay, so we want the motors to move. We are going to move the motors. We're going to move it to the right. Now remember, this steering, if you use positive 100, it moves to the right. If you use negative 100, it moves to the left. I don't want you to remember any other number but positive and negative. So we're going to move it at positive 100. You're going to move it at a speed of 30, a little bit slow. But now you don't, if you move it for one rotation, the robot will just move, the tires will move for one rotation and stop. You don't want to do that. You want to keep it on. So the robot keeps on moving to the right till something happens. And then it's waiting. So you're going to put the wait block here. So what happens? What do you want to do? So you want to keep the robot moving till the gyro angle reads more than 120. So that will create an inner angle of the triangle to 60 degrees. Okay, so remember this is more than or equal to sine. So the angle has to be either equal to 120 degrees with the gyro is reading, or it has to be a little more. Usually it'll be a little more because we know the gyro does an error. This is called a gyro lag. And when it's moving to the right, it's never going to stop at 120. It'll stop at around 125, roughly. We don't know. It might stop at 126. It might stop at 123. That's why you want to keep it more than or equal to. If you keep it equal to, and if it misses 120, it's going to keep on moving because it's not going to find it. So it may keep on turning in circles. That's why initially we always use more than equal to. So remember this sign. So the robot moves to the right at a speed of 30 until something happens. And what is that event that stops the robot? Till the angle is more than or equal to 120. Then what happens? Then you want to stop it. You don't want the motors to keep moving. So again you're going to stop your motors. Okay. Now what do you want to do? So your robot has moved 40. It has stopped. It has moved, turned to the right and stopped after it has created an outer, the gyro has read 120, but that has created an inner angle of 60 degrees. Now remember, you have a gyro lag here. You want to correct the gyro lag. So now how do you correct the gyro lag? So all these steps that you did here, all these steps, you're going to do them in the opposite direction. So I'm just going to copy these instead of just dragging them. I copy these and I put them here, connect it here. So you're going to take your wires here, connect it. So now let's say I'm going to presume that the angle that has the robot has created is 124, but we wanted 120. So now we're going to tell the robot, okay, let's move back in the opposite direction, minus 100. You don't want to go at the speed of 30. You want to go very slow. You may even use 3, you may use 5. I like 3 to 5 is fine. So you could use either. 3 is good. So now after it has moved to the right 125, you want it to move to the left till what happens? Till the angle is equal to 120 degrees. Now because it's moving so slow, it's not going to miss 120. So usually it will stop at 120, and of course after that you stop it. So again, let's try to understand what's happening here. You've reset the gyro. It's reading 0. Robot moves forward for 2.28 rotations. Then it stops, pauses, turns to the right, and you are going to keep it at on. Not for rotation, not for degrees. On till the gyro reads more than or equal to 120 degrees. The motor stop. Now because the gyro lag, it has created an error, and instead of 120 it's around 125. So you're going to turn the robot back in the opposite direction, minus 100. So instead of turning to the right, it turns to the left. You kept it on till an event occurs, till the angle is reached 120 degrees and the motor stop. So that's the first side of your triangle. To create the second side, you have to reset the gyro again, because if you don't reset the gyro, it's going to get confused as to what angle it is creating. So again, we can either repeat all these steps, or the best thing to do would be to put it in a loop, because you are using the same steps again and again. So you're going to select this whole thing, right? Let's see if I have selected everything. You're going to select everything. You're going to place it in the loop. Okay, so I'm having a little bit of problem there. So you're going to place it in the loop there. And where does my loop end? Yep, perfect. So the loop starts here and the loop ends here. Okay, so now the loop needs to know when it ends. So you can't put it at infinity. If you keep it at infinity, it's going to keep on going forever. So you're going to do it at count 3. Why count of 3? Because you have 3 sides to a triangle. So think about it. Your gyro resets. The robot moves for 40 centimeters, turns to the right, creating an inner angle of 60 degrees. Then it moves, it comes back, the gyro resets, moves forward for 40 centimeters, turns again to the right. Okay, the gyro resets, moves forward for 40 centimeters, and then again turns to the right for one inner angle of 60 degrees. And now you have a triangle. Now I have created a robot moving in a clockwise direction. What I want you to do is I want you to create a robot that would move in a counterclockwise direction.